8.2, Properties of Chords. So remember to write down, remember to write down the date, and remember to write down your name. Mine's Tara. So just like in the other video, what I want us to do is consider the following circle. Let's just zoom in on it a little bit. Now we want to take down a few definitions here. Now this right here is an example of a chord. I have two dots on the circumference. Oh, that wasn't as straight as it could have been. And a line segment connecting. Now I say a line segment because truly a line extends in both directions. You'll know that. You'll get to know that a little bit better in later math classes. But we have a line segment with a beginning and an ending, and there's a straight line that goes between them. So if we were to take down this definition, it would be a chord is a line segment connecting any two points on the circumference of a circle. Now, a diameter is a very special kind of chord because if we say that this, I'm just eyeballing it here, but if we say that this is a center, oftentimes we call this O. A diameter is a chord that goes through the center, just like that. And remember, this is a total side note, but a radius is half of a chord, and oftentimes we need that for different formulas. So a diameter is a chord that goes through the center of a circle. So both of these are chords, but the diameter is a very special kind of chord. So to help us understand the theorem that we're about to talk about, I made this visualization. Now I have a link to it right here that you can just type in. Just be aware that this is all lowercase, it's case sensitive. So if you wanted to play with it on your own, that would be totally great. So we have this right here. We have this circle. So we have this chord. Oh, hello. We have this chord here. This point, oh, it's kind of in the way. This point right here is C, and this point right here is D. And we have a center, which in this case I called an A. Now we have this moving point here. We have this moving point E. So as we get closer to one of the sides, one of the angles, this one right here gets much bigger, and this one gets much smaller. What happens if I kind of slide this slider kind of in the middle here? What happens to our angles here? Well, it becomes perpendicular. So CD is perpendicular to AE. Another thing that's pretty cool is that both of these sides, DE to EC, they're the exact same. They're both 2.3. And another important feature is that that EA goes through the center of a circle. Now this is kind of like the three pieces of really important information that we are going to be working through and using in all the examples today. We have perpendicular, okay, lines that are perpendicular to chords. Those lines or line segments go through the center, and the line bisects the chord. It means that it splits it exactly in half. So I encourage you, if you wanted to go and play with this app, this little applet, go for it if you want. So let's go back to our notes here. So there are three important parts to the circle puzzle. So there is a line going through the center of the circle. And that line is making a 90-degree angle to a chord. Just to help me not have to write perpendicular all the time, I'm going to be using this one right here. So this means perpendicular, which means 90 degrees. And the line splitting the chord in half. This is called bisecting. Or it's the act of bisection. So what's really cool about these properties is that any two of these, so a line going through the circle and that line making a 90-degree angle to the chord, any two implies the third. So it depends on what you start with. Now please note that this is a different color because yours is in black and white. So let's pay attention to here. What are the things that we're given? The things that we're given are the items in black. So what I can say here is if a line goes through the center and makes a right angle with a chord. So we have a line goes through the center, so 1, it makes a right angle or is perpendicular to, so that's the second one. Then, so we have the perpendicular, we have the line going through the center of the circle, and what does that imply? It implies that that chord AB is bisected. Let's look at the next one. So in this case, the O, the center of the circle, is red. So that's the thing that's implied. So what we have is, so if a line is perpendicular, okay, so that sign means perpendicular, to a chord, and that chord is bisected. Okay, so we have the perpendicular, we have that chord being bisected. So that implies, so then the line goes through the center of the circle. Cool. And now the last one. So we're noticing that our right angle is the thing that is the result, or the conclusion. So what do we have here? We have the bisected chord, and we have the line going through the circle. So the way that we can write this one down is if a line goes through the center of a circle and bisects a chord, then the line is perpendicular. I'll write it out this time. To that chord. Okay, so it feels kind of like we have run around in a few circles here, but let's do some examples to kind of just ground our learning and to practice it. So example number 1. Point O is on the circle and point O is the center of the circle and the line segment OC bisects the chord AB. Angle OAC is 33 degrees. Determine the values of X and Y. So let's see what we have. In math we call this given. So we're given line through center. Okay. And we're given bisected chord. So what that implies is that line OC is perpendicular to AB. So what I'm going to do is I'm going to draw in my little right angle right there, because we can use this very helpful information actually to discover what Y is. So in triangle OAC, we have, so we're talking about OAC. We have two angles. We have 33 degrees and 90 degrees. So to find Y, we're going to go 180, because we know there are 180 degrees in a triangle, minus 33 minus 90. So we're going to say that Y is 57 degrees. Now to find X, I'm going to redraw this triangle right here. We don't need to know, basically the only thing that we're going to be using here is the idea of a radius and how it's consistent. So you're noticing that O, just going back up to the other triangle, the other circle here, so OA and OB have to be the same length. Why? Because they're radii. So OAB, I'm going to say OA equals OB because since both are radii. So that means that I can make little tick marks here. Psh, 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 psh. And I know that this guy right here is 33 degrees. We want to find X. So since triangle OAB is an isosceles, angle X, the measure of angle X equals 33 degrees as well. Because when you have the lengths the exact same, the angles that they make with the base are the exact same too. Awesome. So, example number 2. Point O is the center of the circle. AB is a diameter with length of 26 centimeters. CD is a chord that is 10 centimeters from the center of the circle. What is the length of chord CD? Give the answer to the nearest tenth. So let's talk about what we're given. So we're given that the line goes through center. Check. And we're given, also given that line is perpendicular, line is perpendicular to chord. So in another way we can say OE is perpendicular to CD. So what that implies is that the chord CD is bisected. So that means that we can say C E equals DE. So we can say boop, boop. They're the exact same. That's what the tick marks mean. So what's so cool about these is that they're just a whole bunch of mind puzzles, and we can use what we've been given to kind of unfold this a little bit. Now, a very important trick in these kind of questions is knowing your radius. So if I say that diameter is 26, we can say therefore radius is 13. I should use the units there, 13 centimeters, because the radius is half of a diameter. So a very important trick here that you can use time and time again with these kind of like circle problems is that you can draw from a center to this chord right here, and I know what that length is. So if I know that this one right here is the OE is 10 centimeters, I know what the radius is as well. I know that this is 13 centimeters. So I'm just going to redraw that triangle that we have here. So E, D, O, no, this one. I know that this one right here is 13 centimeters. I know that this one is 10 centimeters. I can use the Pythagorean theorem to find it out. So I'm going to call this B. So C, oh, I should change the color here just to make it easier on the eyes. So C squared equals, since we know the radius, we're going to use the subtraction actually. So I'm going to say B squared equals C squared minus A squared. And now what I'm going to do is I'm going to substitute what I know. So my B is going to be ED squared, ED squared. My hypotenuse here is 13. So I'm going to say OD squared minus OE squared. Now I'm going to fill in all the numbers that I know. ED squared is 13 squared minus 10 squared. ED squared is 169 minus 100. ED squared is 69. And then I'm going to take the square root of both sides. And so that means that ED is 8.31 centimeters. Okay, cool. So we know that E to D is 8.31 centimeters. But we want to find the whole thing, C to D. So what I'm going to do is I'm going to multiply that by 2 because I know that these two CE and ED are the exact same. So CD is 2ED. So I'm going to say CD equals 2 times 8.31. CD is 16.62 centimeters. But the question asks us to the nearest tenth, so I'm just going to say CD equals 16.6 centimeters. You're noticing that I'm keeping more than one decimal during the question, and then I round to the nearest tenth at the end. That's the proper way to do it, because you don't want to round too early. That can be a problem. All right, last but not least, the word problem. A horizontal pipe has a circular cross-section with center O. So that's what this represents here. So it means that we have a pipe here. You don't have to draw this. We have a pipe here, and what we've done is we've cut it right here. That's what a cross-section is. So this is what we're looking at right here. Its radius is 20 centimeters. So we're not given a diameter, but we're given its radius. Water fills less than 1/2 the pipe. The surface of the water is 24 centimeters wide. Determine the maximum depth of water, which is the depth of CD. So we're looking for this right here. So again, this is just a puzzle. So let's look at what we have and what that implies. So what we're given is the line goes through center, and we're also given line is perpendicular to chord. So we're saying that I can even say OD is perpendicular to AB. So that means that, the chord is bisected. So I can say that this equals this. Cool. So it kind of looks like we're not given a whole ton of information here, but if but we have a really important piece right here. AB is 24 centimeters. So if AB is bisected, okay, that means from A to C is going to be half of that, so that's going to be 12 centimeters. Cool. So I'm going to redraw that triangle just to make the original diagram just look a little less messy. So we have A, and we have C, and we have O, and you're noticing that I'm always writing down the letters because that just helps us name it and helps us with our showing of our work. Helps us organize our thoughts. So I can use Pythagorean theorem because I know that this angle is a right angle. So I'm going to say, we know what the hypotenuse is, so I'm going to call this B. I'm going to say B squared equals C squared minus A squared. I'm going to fill in with the letters in this exact scenario here. So that means that OC squared is OA squared minus AC squared. OC squared equals OA is 20, so 20 squared minus AC is 12, so 12 squared. OC squared equals 400 minus 144. OC squared is 256. Ooh, that's nice. That's a perfect square. So I'm taking the square root of both sides. OC equals 16 centimeters. Okay, so we know what OC is, but we need to figure out what CD is. But we're going to use the oldest trick in the book, and that's knowing how to use our radius in the right way. So I'm just going to redraw it, maybe a little bit bigger, definitely less perfect. And I'm just going to kind of make it so that I'm exaggerating a little bit. That mathematicians can do that because they always have the caveat, this diagram may not be to scale. So I know that this radius is going to be 20. But guess what, folks? From a center to the edge, this is also 20. I'm just going to write in my letter so that we can kind of ground our explanation a little bit. We just found out that OC is 16. So if OD is 20 and OC is 16, we can find out what this little section here is, no problem. So what I'm going to do is I'm going to say that OD equals, CD equals OD minus OC. So I'm going to say CD, so this little section right here, CD equals 20 minus 16. So that means that CD equals 4 centimeters. Boom. So like I said, folks, this is just a whole bunch of brain puzzles. This is the very definition of brain candy. So if you can kind of develop some strategies, specifically knowing when to use your radius and knowing when to draw a new one, that's going to make these questions a lot easier. So let's write the summary here. So the perpendicular to chord theorem requires two conditions to imply the third. This can be very helpful when solving for circles.